Hi. So in the last video, we talked about stacks and the LIFO principle, that is last in, first out. Now today we're going to be diving into a new data structure, which is the queue data structure. And what we're going to do is we're going to explore what a queue is, how it works, using the FIFO principle, which is first in, first out principle, and we look into the main operations that is in queue and the queue. So just to get started, the first thing we need to understand is the basic definition of a queue. A queue is a linear data structure. Let me do this. So a queue is a queue is a linear data structure that follows the FIFO principle, and the first element is the first one to be removed. So think of it like in a movie theater or a queue at a ticket counter or any queue really. Even when you're going to the airport or even the train station, the queues that you get into. So the first person or the person who's in front of the queue is the one who gets served first, and then like that until the last person. So that is why we refer to it as to be following the FIFO principle. The first element in is the first element that gets out as well. So just imagine a line of people waiting for tickets, and you can use this down here as an example. So this is the front of the queue here, and this is the back of the queue, right? Now, the first person in the line gets served first, and then people join. People join the end of the line. So people don't join from the front; they join from the back. And some of the use cases of this queue data structure or queues in general in the real world, we use them in managing tasks, in printers, in CPU task scheduling, and even handling requests on servers. Now, at some point after the end of this series, we're going to be building a number of task scheduling systems, and you're going to see how some of these things apply practically. Yeah. So how it works is a queue data structure has two primary points. It has the front or the head, and it also has the rear here, which is now the back of the queue. So elements are removed from the front, and new elements are added from the back here. So we operate from both hands, which helps us maintain the FIFO order. The key operations in queues are two main operations. The first one we have is enqueue, and enqueue is basically adding an element to the rear of the queue, that is at the back of the queue. As you can see here, we have like this element here, 9, that you're trying to add to the back of the queue here. And the other operation that we have is the dequeue operation. And the dequeue operation is for removing an element from the front of the queue. So if someone gets served if in front of the queue, then we remove them, and that operation is known as a dequeue operation. So some of the steps that we follow, and we can start with basically how to enqueue first. Some of the steps that we follow when we are enqueuing, the first one is, first of all, to check if the queue is full. So we have cases where you can find that you have a limited size queue. So that is why we need to check, first of all, whether the queue is full. And then we're going to insert new elements at the rear. That is now the second step. If the queue is not full, we check if there's a new element at the rear. And then we go ahead and update the rear pointer to the next position. So this rear pointer is going to be moved to the next position. So an example of this, imagine that you want to add numbers. Imagine that you want to add numbers to a queue, and the current queue could have, let's just demonstrate them down here. So we have, let's say, element, we're representing them in form of an array. We have these three elements, and the current queue has these three elements, and we want to enqueue four onto the list of items that we have here. So now the new queue is going to look like this. The new queue is going to have 1, 2, 3, and 4, like that. So this is basically what we mean by enqueuing. So we're going to first of all check, and then we're going to add the elements here. Now we do understand when it comes to, if you're representing using arrays, there is how, in case we want to add an element to a new array, to an array, we have to go and create a separate array. And the reason for that is because arrays are sort of fixed in size. When you map them into into memory, if the initial array that you had only had let's say 3 items, or had a size of 3, we want to add another element, you'll have to discuss this entire array. Since you can't add elements here, then you're going to create a new array that can handle the new size the new size that you have. And the reason for this, you can get into more details. So you can obviously refer to the video that we did on arrays. The reason for this is because of how items basically are added to memory. So it's not a guarantee that in your array there's going to be a space next to it where you're going to add an element. It could be handling other things, right? But kindly refer to that video to get into more details. Now, the other operation is the dequeue operation. And like you said, the dequeue operation removes an element from the front of the queue. And the steps that you follow, the first step is here, we were checking the first step that we are doing with NQ is we were checking if the queue is full. But when you're doing a dequeue, the first step that we do is we check if the queue is empty. And once we check if the queue is empty, if it is not empty, we proceed to step number 2. And step number 2 is now removing the element from the front. So we can actually just write the steps here. So when you're talking of the queue, the first step is check if empty. So we're going to check if the queue is empty. If it's not empty, we remove element. We remove a element that is at the front, right? And the third step is for us to update the front pointer to refer to the next element. So we just update the front pointer. These are the operations that we do when you're talking of dequeuing. Yeah. So again, same thing. We can use this. What we have here. Let's say we have an element. We want to remove an element from this queue here. After dequeuing, we're going to remove one is the one that is at the front of the queue. So after dequeuing, we're going to remove that one, and the pointer is going to move to the next element, which is 2 now. Right now, 2 becomes one that is at the front of the queue. So we can also just quickly update the steps here for enqueuing. So for enqueuing, the first step we are doing is we were checking if the queue is full. So we check if the queue, let's just check if full. So we check if the queue is full. Okay, so we check if the queue is full, and then the next step that we're going to do is if the queue is not full, we're going to insert a new element there. And the third step for us here is to just update the pointer as well. But now in this case we're updating the rear pointer. We're updating the rear pointer like that. So these are the 3 major steps that we follow when you're talking about when you want to do a dequeue operation or when you want to do an enqueue operations. Yeah, just to do a quick recap of these operations that we've checked here. The first operation that we've checked is on enqueuing, and what we've seen is that enqueue is when you want to add an element from the rear here. And the other one is dequeue. Dequeue is when you want to remove an element from the front of the queue or from the head of the queue, right? And the queue data structure, one of the major key takeaways here is that the queue data structure follows the FIFO pattern. And the FIFO pattern, of course, stands for fast in, fast out, right? And that is basically it about the queue data, the queue data structure and the operations that you can do on a queue data structure. We're going to look at a few more things later on, but so far we've covered the basics of queues, the FIFO principle, and how the NQ and DQ operations work. And what you've also learned here is that queues are fundamental in ensuring a fast come, fast served order in data processing. Yeah. So we're going to go ahead and look at other types of queues and a few more details into the queue data structure in the next video. Thank you for watching. I'll see you in the next one. Cheers.